All right, we're getting really close to the end of the semester. This is going to be section 5.4. And it's titled The Fundamental Theorem of Calculus, so it must be a big deal with a name like that. And this section kind of ties together the last section with what we do for the rest of the semester. In the last section, we found areas. We estimated areas using trapezoids, and then we found exact areas using our calculator. In this section, we'll learn how to find the exact areas using calculus. And essentially, what the fundamental theorem of calculus does is, instead of doing, so what we did in section 5.3, is we estimated areas using, I'll say, n trapezoids, and we varied that n. And the bigger the number the n, the better the estimate. And essentially what the fundamental theorem of calculus does is it takes the limit as the number of trapezoids goes to infinity of the area of the trapezoids. Probably the sum of the area of the trapezoids. That's, in more understandable terms, what the fundamental theorem of calculus basically says is that if I can do infinitely many trapezoids and add up their area, the area of each of the individual trapezoids, then I'm going to get an exact measurement of the area that I'm trying to find. Specifically, the fundamental theorem of calculus says this. It says the antiderivative from a on the bottom to b on the top. Now we're getting numbers on the top and the bottom of the integral sign of some function f of x dx equals, and this, when I was a student studying calculus, was just too much for me to even see. I didn't even need to see it because I could never understand it, but I feel obliged to write this down and try to talk through it for a second. So I'm writing a bunch of junk down, and I'll quickly talk about it. So what the fundamental theorem of calculus says, if we have a function f of x, and I want to find the area between the graph of that function and the x-axis over some interval ab. So for instance, say my graph of f of x, say a is here, b is here, and the graph of my function over that interval is here, then if I want to find the area beneath the curve, between the curve and the x-axis, so pictorially, this is saying we calculate, this is the area that we want to calculate. This is a graph of f of x, some random f of x, and if I want to find the area beneath the curve above the x-axis, or between the curve and the x-axis, from some value on the x-axis, what we'll call x sub 1 equal to a, and x sub 2 equal to b, then we have to evaluate f of b minus f of a, where the derivative of f is that little f, or the integral of little f is big F. And this theorem only works if the function is continuous on the integral. So what we're going to be doing in this section is finding areas. And we're going to find areas by simply taking the function and finding its integral, and then plugging values into the integral and subtracting the results. And let me just kind of do a few problems. Once I do a few problems, this theorem that looks really impressive, it's not so impressive, and it won't be that hard to understand. So for the nice thing about this section is that for essentially every problem, I can get an answer on my calculator, which is a thing of beauty. Really? Oh gosh, this is 8. Yeah, let me change mine. Let me change my problem too just slightly, just because it's for the first example, I want the picture to be kind of just like the pictures we were getting in section 5.3. So I'm staring at a problem. It's asking me to find an area under a curve, an area between x equal to 3 and x equal to 6 of the function 2x minus 5. And how I can do this on my calculator is break my calculator out, graph this function, so y equals clear 2x minus 5. I probably can do a zoom standard and my calculator can still find the right area. If I wanted to, I can go x min equal to 3, x max equal to 6, but then I'm going to have to change the x min and x max for every problem, and I don't really have to. So I'm just going to do a zoom standard and leave my window at that. And now I'm going to ask my calculator to find the area between the graph of 2x minus 5 and x equal to 3 and x equal to 6 on the x-axis. So I'm going to go second calc, just like we did in the last section, go down to option 7, type in the lower number, which is 3, type in the upper number, which is 6, and it magically draws the area, and it tells me the area is 12 square units. So the answer to part A of number 2 is the integral from 3 to 6, or the antiderivative of the function 2x minus 5 dx equals to 12. So the area between x equal to 3 and x equal to 6 between the graph and the x-axis is equal to 12. Now I need to do that in part B using the fundamental theorem of calculus. And the fundamental theorem of calculus says that if I find the integral of this function, I can get this same value. So I'm going to integrate each term. And how do I integrate? I add 1 to the exponent and divide by the new exponent. It might help to think of this function as 2x minus 5x to the 0. And now I'm going to add 1 to the exponent. That x had an exponent of 1. I'm going to add 1 to the exponent, divide by the new exponent. For the next piece, I'm going to add 1 to the exponent, divide by the new exponent. Previously, we've been putting a plus c on. It turns out it's not going to be necessary in this group of problems because it's going to cancel out. And the numbers that were on the integral sign, I'm going to put the numbers here. Let me simplify this before I start dealing with the numbers. So the integral, or antiderivative of 2x minus 5 is going to be x squared minus 5x plus c. What I need to do to get this number 12, the area under the curve, is do two computations. I need to plug 6 in for the x's here and plug 3 in for the x's here, get values for each and subtract the values. So first I'm going to plug 6 into this expression. I'm going to go 6 squared minus 5 times 6 plus c. And then over here I'm going to do the same thing with a 3. I'm going to go 3 squared minus 5 times 3 plus c. This parentheses comes out to be 36 minus 30 plus c minus, and this comes out to be 9 minus 15 plus c. So this whole parentheses comes out to be 6 plus c. This whole parentheses comes out to be negative 6 plus c. Now I'm going to drop the first parentheses and the second parentheses. The first parentheses, when I drop it, I don't need to change any signs because there isn't a minus in front of it. The second parentheses, the minus in front of the parentheses is going to cause that minus 6 to flip to a plus 6, is going to cause that plus c to flip to a minus c. The c's cancel here, and I get 6 plus 6 equals to 12. So I've used my calculator to find the area that's described by the integral, and then I confirm that using calculus. And so this is exactly what we're going to need to show. In each of the problems in this section, when you do the two parentheses, if you put the c's in, the c's will cancel 100% of the time, because the first parentheses will have a plus c, the second parentheses, because you'll distribute the minus sign, will have a minus c. So I don't need to do the plus c's in this section. When there's numbers on the integral symbol or the antiderivative symbol, this is called a definite integral. It means I definitely know what the answer is going to be, and there's no kind of, it's not arbitrary in some sense. But that's not so important. But what's important here is I don't need the plus c to get my answer. So ultimately, the answer to 2a is 12, and the answer to 2b is 12. But when we get to the test, how you get the answer is going to be a deal breaker. If you don't, for 2b, show the work to get the integral, then you won't get full credit. In fact, you probably won't get any credit if you don't show any work. So I've done exactly what I needed to do. First, I used my calculator to find out what the answer is, and then I used the fundamental theorem of calculus by taking the two pieces, adding one to the exponent, dividing by the new exponents, taking the numbers that were on the antiderivative symbol, plugging them separately into this result in parentheses without the c's, and then find out what each comes out to as a number and subtract the results. That will give you the same area computation. We'll do that for every problem in section 5.4. The only thing that's going to make one problem harder than the next is it might be hard to do that computation. I may have to use u-substitution or something that I'd rather not use. So let me do problem 4 again. So I'm going to do 4a and 4b. They have to have exactly the same answer because I'm computing exactly the same area. So for 4a, I'm going to enter the function into y1 at 8x up arrow 3 minus 6x squared plus 2x. Just graph it. Be nice to see the entire graph. I may not. And now I'm going to go second calc, go down to option 7. The lower limit is 0. The upper limit is 2. And it shades the area for me, and it tells me the area that's described by this, the area between the graph of 8x cubed minus 6x squared plus 2x and the x-axis is equal to 20. That's all I have to show for 4a. That's the answer to 4a. There's no work to show. Now to move on to 4b, I have to find the integral. So for each one of these terms, I'm going to add one to the exponent and divide by the new exponent. So this right here, when I integrate it, I'm going to get 8x to the 4th over 4, and then minus 6x cubed over 3 plus 2x squared over 2. I don't need the plus c in this section because it would cancel out when I plug the numbers in anyways. But I do need to keep in mind that 0 to 2. I'm going to just write that off to the side, but I'm not going to plug them in until I simplify this. This first comes out to 2x to the 4th. The second comes out to minus 2x cubed. The last comes out to positive x squared. And I'm reminding myself I need to plug both 0 and 2 in for x. So now I'm going to set myself up with two parentheses with a minus sign between. In the first parentheses, I'm going to take these three x's and plug 2 in. So I'm going to go 2 times 2 to the 4th minus 2 times 2 cubed plus 2 squared. And in the second parentheses, I'm going to go 2 times 0 to the 4th minus 2 times 0 cubed plus 0 squared. At some point, you can use your calculator. And what I want to see in your work is what each parenthesis simplifies into a single number. So if I want to get this parenthesis down to a single number and using my calculator, that's okay, and I'm going to do that. So the first parenthesis, I go back to the main screen, go 2 parentheses 2 up arrow 4 minus 2 parentheses 2 up arrow 3 plus 2 squared. Hopefully I did that right. I get 20. The nice thing is I'll be able to tell if I make a mistake if I don't get the same answer. This next parentheses, let me do it. I'm going to go 2 parentheses 0 up arrow 4 minus 2 parentheses 0 up arrow 3 plus parentheses 0 squared. And the inside of that parentheses comes out to 0. So I'm not entering the big parentheses that are around each of these. I'm just entering this stuff on my calculator because I don't really care to do that grunge by hand. First parentheses comes out to 20. I can drop that parentheses. I'm going to keep this minus sign, drop that parentheses. I get 20 minus 0, which is 20. So my answer to 4b is the same as the answer to 4a because they're both doing the same computations. My calculator's finding the same area that I'm finding by hand. But on our tests, if you just don't show me any of the work, you're not going to get credit. You're going to get hammered pretty hard. So give 3 a try, and I'll move on to number 6. So first thing for number 6, I'm going to do part 6a on my calculator. And my answer to 6b is going to be the same. So let me just enter this. So y equals clear 3 second square root of x. My calculator doesn't care about fraction exponents. It doesn't need them. I'm going to graph it. Oh, and I'm going to get an error because my window needs to go up to 16 and my window only goes up to 10. So when the value on these integral symbols are bigger than negative 10 to 10, your window has to cover a number, that number. So I have at least half my x max has to at least go up to 16. I'm going to bump it up to 20, not that it really matters. As long as I picked 16 or bigger, it would be okay. I can't see the top of my graph, which maybe might bother you, but it doesn't matter in terms of the computations. My calculator can still get the area if it can't see the y's, and can't get the area if it can't see the x's. So I'm going to just leave my y window how it was. I'm going to go second calc now, go down to option 7. Lower limit is 1, upper limit is 16, and my area is 126. Wow. So that's going to be the answer to parts A and part B. But again, if this was a test question and you just did that, you would get drilled. So let me do this better. So to get the answer of 126 by hand, I have to rewrite this problem so it doesn't have that radical. Square roots turn into 1/2 powers. And now I'm going to drop the symbol because I'm going to integrate. And to integrate, I'm going to add 1 to the exponent. And when I add 1 to the exponent, I'm going to add it in the form of 2/2. So my new exponent, 1/2 plus 2/2, is going to be 3/2. And then I have the choice of dividing by 3/2 or multiplying by 2/3 because those are equivalent. And usually, instead of dividing by a fraction, I multiply by the reciprocal. So I'm going to multiply by 2/3, and I'm going to bring down the numbers on the integral symbol of 1 and 16, and I don't need the plus c. The 3's here are going to cancel, and I'm going to get equals 2, and I'm going to write this as the square root of x cubed. The 2 would go there, but I don't need that, from 1 to 16. So I'm writing it back in radical form. I don't know that I really need that, but I'm going to. And now I'm going to make my parentheses, separate it by a minus sign. For the first parentheses, I'm going to plug in 16. I'm going to go 2 times the square root of 16 cubed. And the second parentheses, I'm going to go 2 times the square root of 1 cubed. And I don't really care that I can impress you to do this in my head to figure out that is, oh gosh, 4 cubed 64. This one comes out to 128. This one comes out to 2. I don't care that I could do that in my head. I can do it on my calculator, and that's good enough for me. So on my calculator, I go back to my main screen, and I need to do each parenthesis separately. I'm going to go 2 I don't need that. I'm going to go 2 second square root 16 up arrow 3. Gives me the 128. And then I'll do this one, 2 second square root 1 up arrow 3. And you get 2. So this is what I'd need to see on a test to get full credit, and there's the 126 that comes up. All right, so you don't need to tweak your window for number 5 because the x max is only 9. But when you get to number 7, you're going to have to tweak your window. So it kind of doesn't matter what the y's are because I don't need to see everything so perfectly. So as long as my x maxes can handle the numbers on the integral symbol, I'm okay. So your x max for number 7 is going to need to go to 25. My x max only needs to go to 9. I have it at 20 right now. There's no point in resetting it. So let me do 8a, which is going to be 8a and 8b are going to have exactly the same answers, but 8b I need to show work to do it. So for 8a, y equals clear 2 second square root of x, close out the parentheses, minus 6x, graph it. Interesting. So now the graph is beneath the x-axis, and you're going to find out what happens when we get an area beneath the x-axis real quickly here. So I'm going to go second calc, go down to option 7. The lower limit is 1. The upper limit is 9. It gives me a negative area, and negative 205.333. So areas above the x-axis come out as positive numbers. Area below the x-axis comes out as negative numbers. When I do this by hand, I'm going to get the fraction equivalent of this, and I prefer a fraction answer to a decimal answer. So whatever this refers to as a fraction, that's actually negative 205 1/3. And I can make that into a decimal, a fraction if I care to, but I don't really care to. I'm going to get a by hand answer, and my by hand answer, I'm going to math enter it, and so I won't have that ugly decimal answer. Let me get into the work now for number 8b. So my answer for 8b is going to look slightly different because it's going to be a fraction form of that. So I'm going to rewrite this problem as the antiderivative of 2 times x to the 1/2 minus 6x to the first dx. And now I'm going to add 1 to the exponents, divide by the new exponents. For the 2x to the 1/2, the new exponent would be 3/2. So this is going to give me 2x to the 3/2. Again, it's better to multiply by 2/3 than it is to divide by 3/2. Next piece is going to be minus 6x to the second power over 2. And then I need to deal with this 1 and 9. This first term, I'm going to multiply the 2's together, and I'm going to get 4/3. And then I'm going to change this into a radical. The 2 becomes the index that doesn't need to be written. And then I have an x cubed. And the second piece comes out to be minus 3x squared. I still haven't dealt with the 1 and 9, so I'm going to write them down. Now I'm going to make my 2 parentheses separated by a minus. In the first one, I'm going to go 4/3 times the square root of 9 cubed minus 3 times 9 squared. I'm going to make that into a fraction, do it all on my calculator. And for this one, I'm going to go 4/3 times the square root of 1 cubed minus 3 times 1 squared. And I don't care to do either of these by hand, so I won't. So first parentheses, second quit. I'll do 4/3 in parentheses to be safe here, so let me clear this out. I'm going to go 4 divided by 3, second square root 1 up arrow 3, close that parentheses. That's the left half. And then minus 3 and then parentheses 9 squared. It's going to give me a decimal. I'm going to math enter it. That gives me negative 725 over 3. I don't need the parentheses anymore, but I can keep it just for safety. Now I'll go to the second one. The second one I do parentheses 4 divided by 3 and then second square root of 1 up arrow cubed, close my parentheses, and then minus 3 times 1 squared, and math enter, because negative 5 over 3. So now I have a double negative here that's going to go plus. So this is going to be equals negative 725 over 3 plus 5 over 3. That I can do in my head. That I get negative 720 over 3. Really? I have a mistake. I don't know where it is, but I know I have one, because negative 720 over 3 doesn't equal 205.33. Let me see what happens there. Negative 720 divided by 3, get negative 240. That's troubling. I have a mistake. Let me double, triple check. First, I'm going to make sure I entered the function right. Check part A. So that's 2 square root of x minus 6x. Recheck part A by finding the integral from 1 to 9. So that I feel good about. Means somewheres in my work for part B, I have a mistake, I think. So let me try to find it. That's the nice thing about doing the check on your calculator. If your calculator answer and your by hand answer don't match up, then you made a mistake on one of them. And my by hand answer came out to minus 240. And I have no idea where it's at. So I'm going to start this over. So I rewrote it properly with a fraction exponent. Now I'm going to add 1 to the exponent. 1/2 plus 2/2 is 3/2. Multiply by 2/3. That gives me 4/3. That turns into a square root of x cubed. I feel good about that. Here I add 1 to the exponent and get an x squared. Divide by the new exponent and get a minus 3x squared. I feel good about this. It seems right. And which means maybe I made a mistake down here, which it's possible I made a mistake on my calculator. So I needed to plug 9 in for these x's. So I did 4/3 times 9 cubed minus 3 times 9 squared. Looks like I plugged it in right. And then over here, 4/3 times 1 cubed minus 3 times 1 squared. It looks so right. So let me retry these. So second quit. Oh, I could, well, necessary. See, let me try this again then. So parentheses 4 divided by 3, just for safety, times second square root of 9 up arrow 3, close that parentheses, and then minus 3 parentheses 9 squared. Oh, minus 207. Somewhere when I did this the first time I messed up. So this is minus 207 plus 5/3. Now I'm going to do that on my calculator. So I think I found my mistake. I just entered something wrong on my calculator, and that's, hardly believable. Let me finish this up now. I'm going to go minus 207 plus 5 divided by 3, and I want to get that number. I got exactly that number. So now I know my work is right down here, and I'm going to math, enter, enter to make it into a fraction. And the answer that I'd expect to see for this is the fraction version of that decimal. So when the answers are decimals, if it's possible to make the decimal into a fraction, when you're doing the by hand version, I want the by hand version's answer to be a fraction and not an ugly decimal. I put a bar over this because that number repeated. If you just gave me a 2 decimal rounding, it's completely fine. I have no idea if your problem 7 has the same issue that my problem 8 has, meaning that you get a decimal answer. And I have no idea what I did wrong on my calculator, but obviously I did something wrong. And that's the whole reason I'm having us do the part A and the part B. Ugh. 10 is not a pleasant looking problem. Let me get a go. Really seems odd to feel those E's on the integral sign. So let me give my best go on number 10. So clear the function out. Enter 1 divided by x. There's no problem entering that. And now graph it. That's not so hard. And this window is not stellar at all for this particular area. Find the answer. So I can find the answer even if the window I have doesn't show the graph in all its glory. I won't be able to see the shading as nicely, but I don't really care. I'm just worried about the final answer. So now I'm going to go second calc, go down to option 7. The lower limit is e. To get an e on my calculator by itself, I just hit the second and the divide key, and there's the lower limit of e. And then to get the upper limit of e squared, I go second and ln, When I hit second and ln, it gives me an e and allows me to put an exponent in. And there's the upper limit, and my answer is going to be 1. Wow. So the answer to 10a is shockingly 1. Let me try to get there by hand. First of all, there are a few integral formulas that I have to know, and these come up on this sheet right here. Problems 9 and 10 are the special ones. The integral when you have an x to the negative 1 power is going to have an ln in it. And I do have an x to the negative 1 power because my problem in number 10, if I rewrite it without the fraction, I get negative 1 x to the negative 1 dx. In this case, for my formula, the 1 is the a, the x to the negative 1 dx turns into the natural log. So the integral of this is going to be my value of a, which is 1, times the natural log of the absolute value of x, and I don't need the plus c. So this comes out to be the natural log of the absolute value of x. In front of it, I have this number, which is a 1. I don't really need to write that. And then evaluate it from e to e squared. It turns out that the absolute value is not really going to be necessary. It would only be necessary to enter on my calculator if either e or e squared was a negative number. I'd need to make any negative numbers positive, but e is 2.7, e squared is like 9 or 7.29. So I don't need to use absolute values when I do this on my calculator. Next thing I want to do is the natural log of e squared in the first parentheses minus the natural log of e in the second parentheses. These I can do in my head, but I'm going to assume at this point that that's a lot to ask. So I'm going to use my calculator to do both of these. So to do the natural log of e squared, go clear this junk out, do natural log second ln e squared, close, gives me 2. And then the second parentheses, I'm going to go second natural log, I'm going to go natural log second in the divide key for just the e, and that's going to make that one a 1. So this is the kind of work that I need to see if this was your test question. And this is going to give me 2 minus 1, which is 1. My answer to 10b is also 1. For your 9, let me just real quickly do number 9. For 9a, I'm going to graph y equals clear second ln for e to the x. Well, second and ln for e to the x. Graph it. And then do second calc. Go down to option 7. Bottom number is 0. Upper number 2. I get 6.39 rounded to 2 decimal places. That's not going to be a good number for you. So let me show you what your answer should look like. Your answer is going to be equivalent to 6.39, but it's going to have e's in it probably. So for you have to integrate or find the antiderivative of e to the x. You're really finding the antiderivative of 1e to the x, and the antiderivative of 1e to the x is just 1e to the x. This a stays, this e to the x stays. So for your work for 9b, try to squeeze it in here, the integral of 0 to 2 of e to the x dx equals e to the x evaluated from 0 to 2. Make my 2 parentheses separated by a minus. The first parentheses I'm going to have an e squared. The second parentheses I'm going to have an e to the 0. E squared is just e squared. E to the 0 is equal to 1. This is how I'd want my answer for your problem, because I don't want grungy decimals if I don't need to have grungy decimals. And e squared is a number that has a grungy decimal equivalent, but I don't need to write that. I can write e squared, and e to the 0, anything to the 0 power is 1, and I keep the minus sign and drop the parentheses. I'm going to show you that that is equal to that, because that's important. So second clear second ln squared, and then minus 1, and that's entering that. It better be 6.39, and it exactly is. So I want, when answers can have e's in them, I want the e's in them. When answers can have fractions, I want the fractions in them. So that would be perfect for 9. And so I did number 9 for you, I guess. right, so just watch myself do problems 12 and 14. I had a mistake in problem 12 that drug on forever, and I didn't really like the way I did problem 14. So I'm going to redo problem 12 and 14 for you, so the video might look a little bit different than it did just for the last two problems, 9 and 10. I changed an exponent on problem 12. I guess you'll never know what it was, but the numbers came out to be so ridiculously large. I think it had an exponent of 5 that wasn't really something I wanted to have permanently on a video. So, so just like for, well, this problem, I need to integrate it. And part A wants me to use my calculator. My calculator doesn't care at all in terms of how complicated it is to integrate. So let me go ahead and get this answer on my calculator by going y equals, clearing out the stuff that I have in there already, and I'll enter the function parentheses 2x minus 4 times parentheses x squared minus 4x plus 1 parentheses. I could just hit the squared key because I have an exponent of 2. Don't need the dx or integral sign on my calculator. I'm going to hit zoom standard to graph it. And again, I'm not really that worried about what the graph looks like. My calculator can find the area that I'm looking for, even if the window doesn't show the whole graph so well, but I think this window is probably adequate anyways. So now I'm going to go second calc, go down to option 7, hit the lower limit, which is -2, type the upper limit, which is 1, and I get -735. That's a really nice answer. So there's no decimal in that answer. So I feel good that I should be able to match it up by hand. I can't remember if we have already had a negative value. When we calculate areas, any region of the graph that's below the x-axis gets assigned a negative area. So you'll see the shading that my calculator has done here. The entire graph is below the x-axis in the interval -2 to +1. That's why I get a negative area. It's going to come up when I do 12b by hand, and I wouldn't even have to know ahead of time the answer, or that you could have a negative area. My calculus will still produce it. So I want to integrate this function, and because of the parentheses with an exponent, I have to do u-substitution. I'm going to let u be the inside of the parentheses, which is going to be x squared minus 4x plus 1. And then we'll take the derivative of u with respect to x and get du dx. The derivative of x squared is 2x. The derivative of minus 4x is minus 4. The derivative of plus 1 is 0. So what I'm going to do is I'm going to rewrite this. And usually when I use u-substitution, the letters -2 and 1 apply to when the variable is x's. Because I'm changing the x's to u's, I stop writing the -2 and 1 until I introduce the x's back into the problem. But if you left the -2 and 1 when you did the u-substitution, I'd never take points off. But you have to be careful when you do u-substitution to actually change the u's back to x's before you plug the numbers in. So I'm going to do two substitutions here. The 2x minus 4, I'm going to change to a du dx. The inside of the parentheses, I'm going to change to a u. The exponent of 2 I'm going to leave, and the dx I'm going to leave. Just like in all the problems on this video, the dx's will cancel, and I don't really need the parentheses, and I can rewrite this as the integral of u to the u squared du. And simply now I add 1 to the exponent and divide by the new exponent to integrate. I don't need a plus c in this section. I should probably write an equal sign. I don't know why I shoved that way over here and bounced over here, but I just was, I don't know what I was thinking. Before eventually I want to find this answer. And to find this answer, I have to plug -2 and positive 1 in for x, not for u. So before I go do plug my numbers of negative 2 and 1 in, I need to change this u to x squared minus 4x plus 1. The exponent should be 3. For a second I wrote 2, but I scribbled it out to be 3. And this template's going to be improved upon in terms of it's going to be made to what I need when I change the x's to x squared minus 4x plus u to x squared minus 4x plus 1. Now I can plug the numbers in. I'm going to make two parentheses separated by a minus sign. In the first parentheses, I'm going to get something when you plug 1 into this, and that's going to give me 1 squared minus 4 times 1 plus 1 cubed all over 3. And in the second parentheses, I'm going to calculate what you get when you plug negative 2 in. So I'm going to go negative 2 squared minus 4 times negative 2 plus 1 quantity cubed over 3. And now I'm going to break out my calculator and do each parenthesis separate. The final answer doesn't have a fraction or a decimal. I don't know if these will come out to decimals. If they come out individually to decimals, I'm going to change them to fractions. So let me try to do the work I need to do here. Specifically, for the first one, I'm going to go parentheses, and then 1 squared in a parentheses, minus 4 parentheses 1, plus 1, close out that parentheses, do an up arrow 3, that's the numerator, and then divide it by 3. That gives me a decimal. Let me go math, enter for it. I get negative 8/3 for that. For the right side, I'm going to go parentheses, and then parentheses negative 2 squared minus 4 parentheses negative 2 plus 1 parentheses up arrow 3 divided by 3. And that gives me that big number. And I'm going to math enter on it. That gives me 2197 over 3. I'm going to bring down this minus sign, which I already did, and this whole quantity is going to be 2197 over 3. Now to get my final answer for part B, I need to take the negative 8/3 and subtract negative 2197 over 3. So I'm going to go negative 8 divided by 3 minus 2197 divided by 3. Hit enter, and I get exactly the negative 735. So the answer to 12B is also negative 735, and that's perfect because my answer to 12A that I did no calculus for and my answer for 12B match up perfectly. That has to happen every time. It could happen that my answer to 12A is some ugly decimal and my answer to 12B is a nice fraction that's equal to that ugly decimal, but this is perfect for number 12. Why don't you go on and try number 11, and I'll move on to the last problem for this video, then there'll be a part 2. And then the last problem for this video, we have a similar problem. What I did is the x squared minus 4x plus 1 is the same, but I changed the exponent and I changed the contents of this parentheses. It makes the integration a little bit harder, but doesn't make the calculator work harder. So when I go to do 14a, I'm going to pull out my calculator. I'm going to enter this function as y1. I'm going to do a zoom standard graph. Zoom standard is going to be fine because my x's need to incorporate negative 2 and positive 1, and a zoom standard will do that just fine. And then I'll get the dy dx value for myself. So I'll go y equals clear, and then parentheses 6x minus 12 parentheses x squared minus 4x plus 1 parentheses up arrow 3. And this zoom standard, I probably could have just hit graph since I already have a standard window. And again, I'm not super concerned with what the graph looks like. Now I'm going to go second calc, go down to option 7 dy dx. The lower limit, just like in problem 12, is negative 2. The upper limit is positive 1. And this is a huge number, negative 21,408.75. That's not that grungy of a decimal. I still prefer fractions to decimals. When I do this by hand, when I'm doing part B of 14, I'm going to get something that's equivalent to that, that's going to be a fraction. Alright, so let me try to get there by hand. By hand, I want to integrate this. I'm going to need to do u-substitution. You know, it's in some sense maybe disturbing that this number is so large. That has to do with that exponent. In my original version of this video, the exponent was 5, and this number came out to like 1,000,000, and that's part of the reason I made the exponents lower. So let me do the derivative, or the integration first. I'm going to let u equal x squared minus 4x plus 1. Then take the derivative. I get du dx equals the derivative of x squared is 2x. The derivative of minus 4x is minus 4. The derivative of 1 is 0. I look at this 2x minus 4, compare it to that 6x minus 12. That's not perfect, not a perfect match, but always to get this match to happen, you either have to multiply both factors or divide both factors by a number. And I can tell that if I multiply by 3, 2x times 3 will give me 6x, negative 4 times 3 will give me negative 12. So if I multiply everything in this derivative by 3, I'll get what I need to substitute. So I'm going to get 3 du dx equals 6x minus 12. Now I'm going to do two substitutions. That 6x minus 12 I'm going to replace with a 3 du dx. This contents of the parentheses I'm going to replace with a u. I don't really need the parentheses anymore because I'm down to a single variable as opposed to a trinomial. So I'm going to not write that parentheses, although it would be wrong to have it. I'm going to cancel the dx's, and that's going to give me the integral of 3u cubed du. Notice I stopped writing the negative 2 and 1 because those are appropriate for x's but not u's. Now I'm going to integrate this, and to integrate this I just add 1 to the exponent, divide by the new exponent. I get 3u to the 4th over 4 because the exponent is 3. I add 1 and that's my new exponent. And now I'm going to change the u's to x's by replacing the u to the 4th with an x squared minus 4x plus 1 to the 4th. So I'm going to have to pull out my calculator and plug in positive 1 and negative 2 for x. So I'm going to have to do two computations separated by a minus sign. The first computation is going to be 3 times the quantity 1 squared minus 4 times 1 plus 1 to the 4th over 4. And the second parentheses that I need to compute is going to be 3 times parentheses negative 2 squared minus 4 times negative 2 plus 1 to the 4th divided by 4. Lighting is getting weird in here, so hopefully this doesn't mess up what you can see on my calculator. So first parentheses, or first computation, get back to the main screen, clear out the main screen to make it easier to follow. Then 3 parentheses, parentheses 1 squared minus 4 parentheses 1 plus 1 parentheses up arrow 4 divided by 4. Probably going to get a decimal. I didn't, I got 12. So for this first parentheses, it comes out to be a 12. The second parentheses will definitely have to come out to have a decimal because the final answer has a decimal. So second parentheses, I can go 3 parentheses negative 2 exponent 2, or squared I could have done, minus 4 parentheses negative 2 plus 1 parentheses up arrow 4 divided by 4. I get 21420.75. I'm going to math enter that. Hey, it couldn't make it into a fraction. Oh well. because my calculator can't make it into a fraction, I could do it by myself, but because the number, apparently, my calculator is not smart enough to make 21,420.75 into a fraction. Because my calculator can't make it into a fraction, I wouldn't make you do it as a fraction on a test. So if this was a test question and your calculator didn't have the ability to make this into a fraction, I don't want you to do this algebra by hand. So I'll live with the decimal here when I generally wouldn't. And now to get my final answer, I just have to subtract these two, clear out my main screen, and go 12 minus 12 minus 21420.75, and I get negative 21,408.75. So my answer to part B, I certainly would have liked to have a fraction, but I'm not going to fuss too much, I guess, because it's just not doable right now without doing that by hand, and I just don't want to do that arithmetic by hand. So this is the vibe of what you're going to be expected to do on the test for your using the fundamental theorem of calculus to get a area that's associated with an integral. And I'll ask you for a calculator answer and a by hand answer. If your by hand answer doesn't show all the work that it needs to show, you're going to lose a lot of points. Alright, so I'm going to stop the video right here. This is going to be the end of part 1, but there's going to be a part 2.